Alright, let's take a look at another example. The length of a rectangle is 3 centimeters more than its width. If the width is increased by 3 centimeters and the length is increased by 5 centimeters, a new rectangle is formed that has an area of 80 square centimeters, more than the area of the original rectangle. And we want to find the dimensions of the original rectangle. So what this problem is saying is, okay, at first we have a rectangle and which we don't know the dimension. So we don't know what is the width and what is the length, and this is what we're looking for. So that means in this problem we have two unknowns. Okay, and then it says the width and the length, they are increased. So therefore, we generate another rectangle which is bigger than the original one. So the length is increased and the width is also increased. And we know how much is the width and how much is the length increased. Okay. So we said when we have two unknowns, we want to think about which unknown should we set x, so therefore we can make the problem to be easy. And we said to find this answer, we need to look for the sentence which gave us the relationship of these two unknowns. So if we go back to this problem and if we check the first sentence, says the length of this rectangle is 3 centimeters more than the width. Therefore, if we set the width of the rectangle to be x, then according to this indicating word more than, the length will be x plus 3, right? Okay. Now let's look at the in the new rectangle, because the width is increased by 3 centimeters. So therefore, in this new rectangle, the width is gonna be x plus 3, and then because the length is increased by 5 centimeters, so in this new rectangle now, so x plus 3 is increased by 5. That will be x plus 3 plus 5. Remember, we use this whole thing, x plus 3, to represent the length of the original rectangle. So if this is increased by 5, we should add this whole thing by 5, not just x. Okay? Do not just add x by 5. You should add x plus 3 by 5. So this is x plus 8. And then we're given that the relationship of the areas between these two rectangles. It says the area of the new rectangle is 80 more than the area of the original rectangle. So over here, let's recall what is the formula for finding the area of a rectangle if we are given the width and the length. The area is the width times the length, right? So therefore, for the original rectangle, if the width is x and the length is x plus 3, then the area, we can use x times x plus 3 to represent. And similarly, for this new rectangle, the area we can use x plus 3 times x plus 8 to represent, right? Okay, let's take a look at what kind of relationship do they have? Do these two areas have? The new rectangle has the area of 80 more than the area of the original rectangle. So x plus 3 times x plus 8, this is the area of the new rectangle. Since this is 80 greater than the area of the original rectangle, so we plus the area of we add the area of the original rectangle by 80. This will be equal to the area of the new rectangle. Okay. Now, up to this point, we have already successfully set up this equation. So now we just need to solve this equation for x. And before we solve this equation, we notice that we need to simplify both sides. So to simplify the left-hand side, we multiply x plus 3 by x plus 8. So we have x squared plus 8x plus 3x plus 24. This is x squared plus 11x plus 24. Now on the right hand side, we distribute x into x plus 3. Okay. Now, if I want to take all the x to the left, I can subtract x squared, and then I subtract 3x. And to take this number 24 to the right, I subtract 24. So I have 11x minus 3x equals 80 minus 24. So 8x equals 56. So therefore x equals 7. Now once we find the x, remember, what does x represent? X represents the width. So the width is 7. If the width is 7, the length is 10. So the dimensions of the original rectangle is 10 by 7.